Tidal power generation is a system to produce electricity using the ebb and inflow of the sea. Shiwa Tidal Power Plant in the Yellow Sea of Korea, recently completed and operating, is the world's largest tidal power plant, generating 5.5 billion kilowatts an hour electricity annually. Shiwa Tidal Power Plant is a single current type system to generate power only when the tide comes in. When the pressure reaches more than 2 meters of the sufficient level after the inflow starts and when the water level reaches enough to fall from, the floodgates in the front of the generator open to start generation. Then, the power generation stops before the high tide reaches 2 meters. At this time, it takes 4 to 5 hours till the end of generation. At low tide, it is needed to open the floodgates and the hydrological aberration structures and to leave the inland sea empty by discharging seawater for next generation. Changing typed power generation is a system of power generation in both directions of ebb and inflow by inducing the flow of seawater. The production efficiency is twice as much as the single current type. This system is designed in a way to add 2 reservoirs and 3 hydrological structures that can change only the direction of the seawater after power generation turbines are vertically constructed. Generation starts by opening 2 floodgates when the tide comes in and opening floodgates of the generator and floodgate number 4 after ensuring more than 2 meters in the reservoir water level. Then, it is important to ensure the water level reaches the natural state by opening all the 4 floodgates after 4 to 5 hours of generation. At low tide, power generation starts by waiting till the reservoir level difference between the open sea and the inland sea reaches more than 2 meters and opening floodgates. As explained above, it is important to discharge the water to ensure the low tide is maintained by opening all the floodgates after 4 to 5 hours of generation. This system has the advantage that when the water level is maintained in the natural state of the high, low tide, the utilization is rather maximized through water supply and discharge after generation is over. Thus, it is an eco-friendly tidal power system that does not cause environmental damages due to the reduction of the intertidal zone caused by the hydraulic single current type.